Hi everyone, my name is Shantanu and I am with Arnav. Just a quick round of introduction before we get started with observability in distributed systems. I have been working with ThoughtWorks in past 1 year, doing a bunch of stuff around infrastructure and DevOps world. And I've Arnav sitting next to me. Would you like to introduce yourself?
Yeah. So I've been with ThoughtWorks for for a little over 8 years now. I work as an infrastructure consultant here, and I hand over to Shantanu.
Cool. All right. So observability in distributed systems. So from contract testing to observability, they kind of work post your application is developed or deployed. Distributed system means majority of us might be aware of it. It means your service is kind of broken into multiple minute services, decoupled as a containers, maybe running in different container world, Kubernetes, or anything else. So observability, before getting into observability, we wanted to touch base on what happens when we kind of heard the term monitoring. How do you achieve monitoring in real world? So when we think of monitoring, we what we think of is setting up CPU utilization, memory in and out, or disk utilization. These are few of the parameters or metrics we generally, which comes to our mind when it comes to setting up monitoring. Things which we already know, things which we have been doing, we're comfortable with. That's what monitoring is. So it applies to known failure modes, maybe all the metrics which we have just spoken about. Generally, we react after something is broken. That what's monitoring tells us. It doesn't avoid failures, but it tells us that something is broken. It was working a couple of minutes back, and now it's not working. What about the unknowns, things we don't know? Because in a distributed world, you have got multiple application, multiple services, and there are multiple point of failure. So there is no perfect recipe of monitoring which you could just prepare, and you kind of make your system or application fail proof. And that's where observability comes into the picture. uh, it may be a new word, but more or less people coming from ops, infra, DevOps background might be doing more or less, because it consists of logs, traces, metrics. Things are distributed, and that's where observability kind of picks them up together and kind of conglomerate them and give them a single solution, which helps us identifying the holes or traces in a distributed world. So in a distributed system might be you have a front-end application which kind of has APIs in the backend. Now those APIs are again tied back to a database service, could be Mongo, could be Cassandra, could be anything. Let's suppose it's an application, it's a video editing application, and you have your users coming up and saying that my application is kind of responding slow. It's not giving me the response in a proper time. What do you do then? You kind of, being from ops, you don't know how the application was built, because you kind of take care of the support and maintenance of your application, because there are multiple teams, developers who have worked on it. That's where observability comes into the picture, helps you identifying which point your application might have broken down, and which place you need to go and look for to trace down what went wrong and how do you want to fix it. So observability comes into the picture also because none of the system is immune to failover, because every system is supposed to fail at some point of time. You could apply different scaling and permutation and combination to delay the fail, but you would at some point of time need to have certain parameters which can help you understanding how to sustain those failures. So when it comes to accuracy, latency, correctness, consistency, observability plays an important role. These jargons kind of comes into the picture. Let's suppose your application kind of has a response time of 3 milliseconds generally. from past 1.5 years, and suddenly you see that from last 1.5 weeks or 2 weeks, your application response time has increased from 3 milliseconds to 8 milliseconds. Maybe that's not a massive jump, but your observability system kind of tells you with traces and logs that suddenly your response time has increased. You might want to look into your application, go into different direction, and kind of find out why your application is kind of responding a little slower than usual. So that's where observability kind of comes into the picture. Unlike monitoring, it's not failure centric, and both kind of works in tandem. So what we're trying to convey here is it's not probably helpful to conceptualize monitoring relationship between monitoring and observability, because they kind of complement each other. It won't be wise to say observability versus monitoring, because monitoring is subset of observability, and observability might be a new word, but we've been doing some sort of observability with our systems with the help of tracing, loggings and metrics, but maybe using different tools, tooling sets to achieve those logs, traces, and metrics. So why there is a need of observability? Because over the past trends, we have seen that IT teams or ops working on monitoring system, or trying to find the root cause of the broken system, knows that something is not working, but they exactly not sure because they did not build the application, and there are plethora of services which is running underneath the application. So once the user or the ops or the on-call engineers receives an incident or a ticket, they kind of start working on troubleshooting, and it kind of is a siloed analysis, because the user goes into the application, start troubleshooting, start getting the logs, and start analyzing. So it's a bit of siloed, because you're not accompanied by majority of the other team members, and why would you be? So it's a manual process for reactive troubleshooting, and every alert needs a manual fix. And generally, how it works also, right? You kind of receive an alert, and you start fixing it once you have received an alert. Now that alert could be anything. Your disk has suddenly gone up to 90%. Your CPU is kind of hovering around 80 to 85%, and those sort of alerts. But how about with observability? It kind of telling you that with this speed of data ingestion, your disk might be filling up in next 30 days. So you're already aware of the future metrics which might come into the picture, and which gives you a little room to react and kind of work on it in advance. So, in a nutshell, monitoring tells you whether the system works. However, observability lets you ask why it's not working and where did things go wrong. So, observability is about being able to understand the internal state of your system, inspecting the output, because monitoring tells you that, okay, something is broken, not working, and observability is kind of lets you enable to understand why the set of piece is not working. Tracing and distributed system, those who are aware of already, tracing is kind of you have set of application, and let's suppose take this smallest example. You have your Google Cloud and an application running on Google Cloud. You have a client or end users who are trying to hit an application. It's a series of events when a client hits your application or tries to perform any of the crude operation. It's a event which from how does the network calls happens from uh, A service to B service, and what's the topology between all of the services running inside your architecture. On the right hand side, you could see also the series of events, which are the traces, how user kind of, whenever user is hitting your application in the backend, what all services and what all traces are happening, what all activities are running in the background, which you cannot see with the naked eye. However, the some sort of tracing should be able to tell you, okay, first, the whenever a user is kind of trying to request your application, in the backend, there are multiple calls happening, and how much time each service is taken to get back the response to desired state. How can we enable tracing in distributed world, in a microservices world? Simplest answer would be OpenTelemetry. OpenTelemetry is an observability framework for cloud native solution. Uh, about the inception of OpenTelemetry, it was launched a couple of years back. Initially, the instrumentation and API was done using the open tracing. And then in 2017, OpenSenses came up with support for standard libraries. They both were doing similar work around observability. However, there were confusion within a community how they kind of solved the problem, because they were kind of solving similar problems. So CF, Cloud Native Computing Foundation, decided, and they both kind of joined hand together, and then OpenTelemetry was born. It provides a single set of APIs, libraries, agent, and collector, which we would see in our demo how it kind of works. Currently is in beta. Maybe it could point to start off and discovering the services and capabilities of OpenTelemetry. It support majority of your application, be it Java, C++, Go, JavaScript, .NET, and supports majority of the popular frameworks like Redis, Django, Kafka, and Jetty, and a lot of other libraries. In terms of components, it has got specification, API SDK, which kind of binds with your application, and then collector collects all your traces and loggings, and pass on to some sort of visualization tool, maybe Jaeger or Prometheus. We're going to use Jaeger, and Arnav going to show us how it kind of works in tandem, all of the components together. On the right hand side, you see a happy tweet from a customer wherein she's expressing her happiness when OpenSenses and Tracing kind of joined hands together, and OpenTelemetry was born. Why should we care about OpenTelemetry? Because it's a new buzzword, and you kind of want to use it, and it might sound cool. Probably that shouldn't be the only reason. It's one of the topmost project under Cloud Native Computing Foundation after Kubernetes. So apart from its community support, like first class support with Azure and GCP, vendor support like Datadog, Splunk, Honeycomb, all of them integrates pretty tightly. So you've got to get the best out of all of these tool sets as well in terms of visualization. And then you've got users from MailChimp, Postmates, Shopify, to name a few. It collaborates tightly with FluentBit and Jaeger. That's what we're going to use today. In terms of dev stats, we've got 104 plus active members from 45 different companies and more than 40 plus countries, 660 plus unique contributors, and 60,000 plus contribution already made within a span of a couple of years. And the product is still in beta, and the amount of love we are getting from the community is kind of appreciable. Is OpenTelemetry only tool to achieve the observability? Absolutely not. If you're working on any of the cloud vendors like Azure or AWS, you kind of get the tracing out of box. On the left hand side, you see application insights from Azure, kind of gives you a similar kind of tracing and telling you which were the slowest pages, how users are accessing your application using mobile or web, which were the slowest page, how much time did it took to access certain request, post request, and all of the crude operation performed. And then you kind of get the number of counts for 200 successful codes, and error rates as well, 404 or any other. So, and you get a tracing as well, that how your application is kind of traced back to your backend services, and kind of fetching all the services in what time. On the right hand side, you've got the AWS X-Ray. So all of these tools works in a similar fundamental, and kind of makes our life easier if you want to integrate your application with these telemetry or tracing services when it comes to cloud. All right, so that was about the fundamentals of OpenTelemetry. Enough of talking. I'm going to hand over to Arnav now, who's kind of built some of the cool applications and give you some demos around the observability of how you could use it in your real life as well. Over to you, Arnav.
Right. Before we begin, there is a short poll to gather some information around where everyone's comfort and experience with monitoring and observability is. So, Ayush, can you start the poll, please?
Cool. So most people have experiences with Prometheus or Grafana and out of the box cloud native monitoring systems, and then Kibana and Splunk. Cool. The next poll I'll be showing now. Most people indeed find it very helpful, and some find it amazingly helpful. That's the kind of response we were expecting. Cool. Hope the 7% who do not find it helpful finds it helpful after the presentation from Arnav. Yeah.
Right. Okay, then. Thank you for your answers. This does help set up some context here. And let's begin with the demo. I will start sharing my screen and let me know when you can see my screen. Can you see my screen? Excellent. Okay, let me hide floating meeting items. Yes, this is much better. So we'll start with the demo. The demo setup is courtesy of Chris Burns from Keep Gemini. He has a fairly comprehensive demo for testing out traceability and distributed tracing, observability and distributed tracing with Jaeger. The services are courtesy him. The structure is somewhat like this. The application that you see here manages employee records where we store employee names, their designation, and then based on the designation, we figure out the pay grade and the actual salary that they get paid. The microservices is set up as there's a Vue.js frontend, which then talks to a Node.js BFF layer. BFF is short for a backend for frontend, which serves as a single point of communication between the frontend and other backend services. The backend services include three. There are three backend services. One is a salary service, which a salary create service, which is written in Java, which uh, which takes the title of the employee and then tries to figure out what is the salary grade of the employee. Then there is the Java application talks to a Postgres backend, and then there's a Python service which takes the grade and then returns a salary amount for that grade. This Python service talks to a MySQL backend. The third service is a Golang service which actually stores the employee information, and this talks to MongoDB backend. With this in mind, let's probably create some data. I'll probably add Shantanu as an employee in the secret starter that I'm going to start. Shantanu Das is a software engineer. I add his employee, him as an employee, and this is created. Now I'll quickly store his employee ID so that I don't lose it. And I will probably add myself as well. Arnav, Kumar. I'll add myself as a software engineer as well. I have my employee ID. I've created this. And I have my employee ID here. So we talked about, so now that we have the data in place, let's probably make sure that these employees exist. I exist here, so I'm assuming Shantanu will also exist. This is my grade, this is my salary, this is when I joined, and blah, blah, blah. Now, this is a basic application, right? And if you want to see what happened in the backend, what were the interactions, how do we do that? For this, we log into our Jaeger instance, which is at. So this is what the Jaeger UI looks like. The data that we send here is tagged with the service for which we're sending data. So let's if you go back to the structure of our application, we see that the first request falls on the Node.js app. So probably let's start from here. I will go to the Node.js app service. I try to find all traces. And I see that there were 5 calls that were made by the Node.js service. We'll ignore the options ones for now, but there are 3 calls that are of importance for us. The first is a create employee call. This was when I added Shantanu to the organization. The second is the post create employee call, where I added myself to the organization. The third is where I try to fetch my details. Let's now look into the information that is contained here. If I collapse everything, so what you see here, this one full length is called a trace. Now this trace can go across multiple services, and if these services also talk to the same tracing backend, you will see information for them as well. Now these traces are made up of individual components which are known as spans. These spans could be within a particular service, or they're usually within a service, and they track individual interactions within the service. For example, this is so if you go top to bottom, that's the chronology in which the requests have happened. So the first request came to create an employee on the Node.js service. The Node.js service then made a call to the Java service to get salary paid, then made a call to the Python service to get salary amount for the create, and finally to the Golang service to create the employee. Now we can drill down further into the interactions that happen within the Java service. So the Java service is a Spring Boot application, which means that the call came to a controller. The controller it came to the endpoint or the router forwarded this to a controller. The controller then forwarded this to the salary rate repository. This forwarded it to the DTO, I think that's the right term. I'm not too familiar with Java. And this finally came out to the database, where we see the query that was made and the response times that we had. Let me collapse this for the sake of clarity. Let's go to Python now. The Python service, as we drill down, so this is the end call to the endpoint. This gets forwarded to the method within the Python application which manages this information. And the last one is the call that goes to the MySQL backend with the query to fetch the information that we were trying to get. And depending on the capability of the tracing library that we have, be it for Postgres or for MySQL, the richness of information might differ. For example, in the MySQL query, you see the exact query that is going with the query parameter here. But for the Postgres service, you may see a substituted query. This is the query, but it doesn't show you the actual value that was, which is, I think, still fair. Now we go to the Golang service. The Golang service is very straightforward. The call goes to the router, and the router then forwards this request to internally to the MongoDB instance, where again we make a call to the our MongoDB database, and then this is the response that we get back from the database. So this is what is contained within a span that you get for an originating service. If we, let's say, change this to Java service, for example, and then we go and find traces, this still shows you a full view of which request came from where. So this is the same same trace that we saw earlier. If I want now, so we had made 2 calls to create an employee, right? One for me and one for Shantanu. We can also compare the response times that were taken for both of these requests and see which service took more time. So the first call took about 1.2 seconds, but the second call took 127 milliseconds. Now, what we can do, I guess, is compare them as to which services took how much time, and then figure out what was the reason in the discrepancy between such large time gaps. Let me walk you through the code for a bit as to what does it take to instrument your code. What I mean by that is preparing your code so that it can send tracing information to the backend of your choice. This is the code for the Node.js service. The source repository this is the front end. I don't think we've instrumented this bit, but ideally you should be able to instrument your front end code as well, so that you can have traces right from the point where the user clicks a button somewhere. Let's start with the Node.js service. The Node.js service is very straightforward. There's some API presented here. And with this, we also have a section where we initialize a tracer. What a tracer does, this is based on the OpenTelemetry standards. So we're using OpenTelemetry's libraries rather than using Jaeger's native libraries. Here we specify what is the exporter that we are going to use and what is the tracer that we are going to use. Now, if you had to switch this out to let's say instead of Jaeger, you wanted to use something like Zipkin, under most circumstances, the node tracer provider would be the same. The tracing library would be the same. The only thing that would change is the exporter, in where instead of the exporter being Jaeger, the exporter would be for Zipkin. This ensures that there's a fair bit of interoperability between all of these backends. And even if you have services that use different backends, you still have a way of figuring out and diagnosing issues that happen for a particular network. It is similar for Python. Let me do Python here. Python is even more simpler because the setup is less. I go for if I open up the Java library, which is kind of sort of my favorite, because there is absolutely no code for tracing that you need to add here. This is a standard Spring Boot application. You have your repositories, the service just set up and everything else. But all you do when starting this up is as part of your Java application, you also specify that the tracing library should be loaded up. For the Java agent, OpenTelemetry Java agent should be loaded. And then through various environment configurations, you specify which variant of which backend you want to support. All of this is running right now on through a Docker Compose file. And what we can do now is because it's the easiest for the Java service, we will switch over our tracing backend for the Java service from Jaeger to Zipkin. First, let me make sure that my Zipkin instance is up and running, which I can find at localhost 411. Sorry, host 9411. This is what Zipkin looks like. If I run a query right now, there is absolutely no information here because there's no one talking to Zipkin. What I do now is I change the variable names, the environment variables. I comment out the Jaeger specific things, and I restart my Power Compose service. Hang on. Yes, now my Java service is up. And let's try to, so if we go back to our Jaeger UI, you can see that the only cases where my Java service is invoked is when I'm actually creating a user. If I am trying to fetch information for a user, the only service that is invoked is code. So what I'm going to do now is I'm going to create a third user. Let's say, I like Ayush, I'm going to take him away from thought work. So Ayush Sharma, I'm going to make him a lead software. And I add him to my organization and he's created. I take his ID. I see him. He's added to the organization, and we have his details. Now, if I go back to Jaeger and I try to trace this request again, I find traces, and this is the last request that came. So if you look at the traces here, this or the spans here, you still see that there's a first level request that goes to the Java service, but there's no information for the Java service anymore because the Java service has stopped responding to Jaeger. But we still have information uh, for the other services. Just for fun, let's maybe create a couple more. I will add, let's add John if I need a security person. Add him as a lead software engineer. John is also being created. Now, the reason I'm doing this is so that we have some traces in Zipkin as well. And then we can figure out how to find the request for Ayush. Now, if I run my query again over here, so you can see that these are the requests that came in from the Java service. Now, you can probably ignore the ones till here because these came in as part of the Java service starting up. The requests that came here a few seconds ago and a few minutes ago, these are the ones that actually came from the request from the calls that we made. So if I go to one of these traces, so this is what a trace would look like over here. I can collapse this and I can see the various sections that took and how much time they took. Now, if I want to figure out, if I go back here, I run query again, I have two requests that come. Now, it's true, it's easy for us to identify which one was for Ayush and which one was for John. But if I want to actually see the trace that came in for Ayush's request, what I would do is I would copy the trace ID for this trace. Let me grab it quickly. Uh, there is a trace ID, and I go to Zipkin, I search by trace ID, and voila. This is the request that came in for Ayush. Now, the reason this is possible is because both Zipkin and Jaeger uh, are are compliant to the OpenTelemetry standard in the sense that the payload that goes as part of any trace request to these services has a similar basic structure for things like the trace ID, for example, right? The trace ID is something uh, that is honored by both Zipkin and Jaeger, and as a result, it is easy for us to correlate requests across services, across various backends, and to possibly come up with a unified view of how things work. Uh, so that is all I had for this demo. I will stop sharing now once I find my controls, and I guess we are now open for questions.